So today's lesson is really just continuing on with a standard that we began quite a good while back. And we're going to create equations in two more variables, and those equations represent relationships between quantities. And we can graph those, but we want to look at a couple of very specific qualities about equations and graphs, specific things, specific types of lines. And those are parallel and perpendicular lines. So today we're going to be very specific about really just a couple of facts about parallel and perpendicular lines, things that we can use to create equations and be able to label and graph. So to start out with, there's two facts that I need you to write down. And those two facts are this: parallel and perpendicular lines, it's all about the slope in an equation, whether or not they're parallel or perpendicular. First thing you need to be sure you jot down is that parallel lines have equal slope. That's very important. Parallel lines have equal slopes. Means their slopes are exactly the same. If we look at them in slope-intercept form, they'll have equal slopes. So jot that down. And secondly, perpendicular lines have slopes that are negative reciprocals. For example, in particular, you might need to write down the part that's in parentheses. A negative reciprocal is where we take a fraction and we reciprocate it. In other words, the way that you might say it is, and this is not mathematical, but you take the fraction and turn it over, or you flip it, or however you want to call that. But in order for it to be a negative reciprocal too, we have to reverse its sign. Positive becomes negative. Fraction gets turned over. That's a negative reciprocal. Or, if it's negative, then it becomes positive, but the sign has to reverse. I just want to look at a few examples and then give you an opportunity to practice working with parallel and perpendicular lines and writing equations and determining their slopes. So let's look at a couple of sets of equations. We'll start with number one. So jot that one down, please. Number one is y equals 3x plus 2. And the second equation is 9x minus 3y equals 3. So jot those two down. In fact, I've just written them down, and I'll show you what you kind of need to do with that. So the first thing I have to notice is that the first equation, y equals 3x plus 2, it is in slope-intercept form, and I know the coefficient, important word there, I just used it, the coefficient of x is 3. So immediately that I know that the first line has a slope of 3. I don't see the slope necessarily in this equation. There isn't a way to extract it, but we're going to put it in slope-intercept form, which is what we've been doing. In other words, I need to subtract 9x from both sides. So these two cancel out. I get negative 3y is equal to negative 9x plus 3. So I know to do that. And then if I divide everything by negative 3, I can isolate the y, which is what I want to have happen. And it'll be in slope-intercept form. So those cancels. I'll be left with y is equal to negative 9 divided by negative 3 is a positive 3. X, positive 3 divided by negative 3, negative 1. Here, the slope, I can look at the coefficient of x and determine that my slope 2 is 3. My slope is also 3. So since their slopes are equal, then they're parallel. Let's just remember exactly what we mean when we say parallel lines. You should have had that already, but parallel lines are simply two lines that never intersect. They never cross, they stay equal distance. I used to say in the lower grades when I was introducing parallel lines, they're kind of like railroad tracks, but they stay straight. So because their slopes are equal, without even drawing them, without graphing them, without looking at them, I know they're parallel. And it really makes sense because if they're parallel, they have to have the same amount of steepness or sooner or later they're going to cross. Let's look at the second example here. Y equals negative 2x plus 3 and 2x minus 4y equals 8. Again, the first thing I did was to jot those down because I really have to write things down in order to do anything mathematical. Well, the first thing I want to do is identify the slope in the first equation. Okay, so I'm just going to consider the first one for the moment. And it's a good thing because the first equation is already in slope-intercept form. So looking at the x term, the coefficient of x here is negative 2. So the slope of this first one is negative 2. But you're right. My next step is to say, okay, I've got this 2x minus 4 equals 8. And I need to put it in slope-intercept form. And the first step to do that is to subtract 2x from both sides. So it's going to be negative 4y is equal to negative 2x plus 8. Okay, so all I did was subtract 2x all the way through. And I'll need to go through the equation and divide every term by negative 4 so I can isolate y. So when I do that, those cancel, which is what I want to have happen. So this one is y is equal to, now this is negative divided by negative is positive 2 divided by 4. That's a fraction 2/4, which will reduce to 1/2. And so now it's 1/2 plus, and an 8 divided by negative 4 is negative 2. So we'll say 1/2 x minus 2. Coefficient here of x is 1/2. So the slope here is positive 1/2. Now, just examining the two slopes, I've got one slope that's negative 2, and remember that's negative 2 over 1, even if I don't write it as a fraction. If I take this 2 over 1 and I reciprocate it, it becomes 1 over half. And if I reverse its sign, it becomes positive 1/2. So these are negative reciprocals. Which tells me, and those are the way more difficult to recognize, but not really that hard, than the equal slopes. So since their slopes are negative reciprocals, these two lines, they're perpendicular. meaning they form right angles. Okay, and remember perpendicular lines, those look like this. They can be angled any which way, but they form right angles here. So if their slopes are reciprocated or turned over and the sign is reversed, they're perpendicular. If their slopes are equal, they're parallel. So they're pretty easy to recognize. So the next thing we might want to do is we might want to take one equation, use the information we've got to write a second equation. So look at this problem number 3. It says write the equation of the line that is parallel to the graph of 3x minus y equals 5. All right, so we've got an equation, and the first equation is 3x minus y equals 5, and we want to write an equation that is parallel to this line and has a y-intercept. So I'm jotting all that down. Intercept of 0, -7. Just like that. Well, the first thing I need to do is to determine, okay, well, what is the slope of 3 and -y? So if I subtract 3 from both sides, 3x it is, and I'll rewrite it as -y is equal to -3x plus 5, and then I reverse my signs all the way through. It's positive 3x minus 5. There is actually a way to extrapolate the slope out of it in standard form. It's just to put the coefficient of x, as long as they're whole numbers, over the coefficient of y and reverse the sign. 3 over 1, but not negative, positive. So anyway, my slope here is positive 3. So if I want to write an equation of a line that's parallel to this line and has a y-intercept of 0, -7, I have to remember there's only two things I need to write an equation. I need a slope, constant rate of change, and I need a y-intercept, 0, -7, so my y-intercept is -7. So all I have to do is use the y equals mx plus b form of the equation, substitute an m in for x, so it's going to be y equals 3x. There's my slope, my coefficient of x, minus 7. And that's the equation. And that equation there is parallel to the equation I started with and has a y-intercept of -7. Let's look at another problem. This one's a little different. What do you see is different about that one? Well, first, you're given an equation that the new equation we're going to write is parallel to. The 3y equals 2x minus 3. But it passes, this new line has to pass through -3 and 4. Now, in the previous problem, we had a y-intercept. In this problem, we do not. So we got to figure out what to do with that. Well, first thing, I need to know the slope. I need to know the y-intercept to write an equation that's parallel to this line and passes through that point. Well, in order to find the y-intercept, I just divide everything through by 3. So y is equal to 2/3 x minus 3. So I've got this coefficient of x. I've got my slope of 2/3. So I know that I'm going to take the slope-intercept form, y equals mx plus b, okay? I know I've got a slope that is 2/3, and I want it to pass through this point, -3 and 4. All I have to do to find the y-intercept is to take the slope and plug it in for the slope. I need to take the x-coordinate and plug it in there. And I need to plug in the y-coordinate for y. That doesn't seem so bad after all. So y is 4, so it's 4 equals 2/3 times -3 plus b. And solve for b. It's very convenient that 2 divided by 3 times -3, remember that's the same thing as 3/1, and my 3's actually will cancel, so it's negative times positive. So to simplify 2/3 times 3, it's simply 2. And since it's positive times negative, it would be a -2 plus b. Add 2 to both sides so that I can get b isolated by itself. And my y-intercept will be 6. All right, so I've got a slope of 2/3. I've got a y-intercept of 6. So now I can write an equation in slope-intercept form. Y equals 2/3 x plus 6. And I've written an equation that is parallel to 3y minus 2x minus 3 and passes through that point, -3, 4 on the graph. We're going to wrap it up with this example. We've done parallel. But how do we write the equation of a line that is perpendicular to the graph of 3x minus y equals 5? And it's going to also have a y-intercept. So we know the slope is perpendicular and has a y-intercept of -7. How do I do that? So the first thing I need to do is to find out what is the slope of 3x minus 3x minus y equals 5. So I know how to do that. It's -y, subtract 3x from both sides. So this becomes equals -3x plus 5. I don't need to have a leading negative here. So I'm going to multiply everything through by -1. That'll solve that problem. -1 here, and multiply everything on the other side by -1 as well. So I can rewrite that as y equals -1 times -3 is positive 3, and positive 5 times -1 is -5. So I can spot my slope pretty easily. Right there it is. Slope is 3. But I need to write an equation on a line that is perpendicular. So a perpendicular slope will be the negative reciprocal. So I need to take 3 and write it as a fraction over 1. Okay, then I need to reciprocate it. Okay, so I'll turn it over or flip it. And it needs to be negative, so I need to reverse the sign. That's positive, so this would have to be negative 1/3. So my new slope of my perpendicular line is negative 1/3. And my y-intercept is negative 7. All right, if I can get it to that point, I've got this taken care of. All I have to do is write the equation y equals negative 1/3 x minus 7. And that is the equation of a line that is perpendicular to my original equation, 3x minus 5y equals 5, and has a y-intercept of negative 7. So I can create equations using the information I've got and using just 2 facts that parallel lines have slopes that are equal and perpendicular lines have slopes that are negative reciprocals.